So, good evening, everyone. We are here to present our TARP review, and the title of our project is Sars COVID prediction using machine learning. So, we'll begin by giving the introduction. Myself, Shashwat Tiwari, and these are my teammates, Bhavya, Parth, and Akash. So, I'll begin with the acknowledgement, and then we'll move on to the implementation following the steps. So, this is our final review report, and we'll begin by acknowledgement. So we'll like to thank our professor, Dr. Anna Versi, for giving us the opportunity to perform the project, and it has been our honor to do the project, and we have also learned many things. It was a wonderful experience working on this project, and we through this we also learned many things about the AI. And yes, so we'll begin with the intro. So yes, we have seen that in last 2 years, the COVID has taken world by surprise. It emerged as an endemic, and then many people came into its effect. So, and the basic problem with it was that it was contagious, and it was very susceptible and volatile. So the frontline workers and hospital staff were prone to getting the diseases, which made the which made it more dangerous. So the visiting of hospitals for even a small diagnosis became risky. Due to this, patients who were getting smaller symptoms were often very dissatisfied visiting the hospitals, and they often ignored small symptoms, which then developed into a bigger problem, and finally which led to the death. A survey says that if 90% of COVID patient who would have come earlier, and who would have been detected earlier, their lives could have been saved. So yes, this has emerged as a basic problem. So we are basically building a COVID detection project, and the tools runs on the most powerful machine learning algorithms. We have used four basic algorithms for the detection of COVID, and we'll basically input the symptoms. Users can input the symptoms and predict the output through the basic four algorithms. The algorithms we used are KNN, decision tree, random forest, and naive bayes. And we have also designed an interface to facilitate interaction with the system. And we have also attempted to show and visualize the result of our study through this project. So yes, now we'll go on to the literature review, and we have done literature review about 35 basic projects, which are research paper, which are through which we have explored the various existing works on the same field. We have gone through the efficient heart disease prediction and other algorithms, which have made our understanding more deeper in the same project. So yes, this has been the our project, and we have basically done 35 projects. Now moving on to the proposed architecture, which will be given by Parth. So yes, Parth, you can carry on.
Hello, I'm Parth, and I will continue with the proposed architecture. So, other existing disease prediction project predicts the diseases based on any single algorithm, in which we may or may not get the accurate results all the time, because the problem here is no machine learning algorithm works best for every problem. So initially the data is collected, and then the data is prepared, and the required model is chosen and trained. The trained model evaluates the input by user, and the same goes in the following way. User is initially asked to fill the details: name, symptom, which can be minimum of 2 and maximum of 5. And these symptoms are tested against the following conditions. Every disease is predicted using four algorithms, which are decision tree, random forest, naive bayes, and KNN, while using a holdout test set of data to evaluate performance and select the ideal result. While aggregating the final result, the system may arise with five different cases, which can be as follows. So the case one would be where all the four predictions would be same. Say disease A. In this case, the system will display the disease A as the final prediction, and when the final prediction button is clicked. In case 2, any three of the four predictions may be same, say disease A, with different with the remaining fourth prediction. In this case, the system will display the disease A as the final prediction when final prediction button is clicked. While in the third case, any two of the four predictions may be same, and the two remaining predictions would be different. In this case, the system will display the common the common predictions in the first two predictions. In the fourth case, any two of the four predictions may be same, but the remaining two predictions would be similar to each other. In this case, the system will select the disease which is not predicted by algorithm with the lowest accuracy as compared to remaining algorithms and displays it as the final prediction when the final prediction button is clicked. And in the final case, all the four predictions may be completely different from each other. In this case, the system will display all the four diseases except the one that is predicted by the algorithm having lowest accuracy as final prediction. The tools that we
So yes, yes. Now we'll move on to the novelty, which will be discussed by Akash. So Akash, you can carry on.
Yeah, I'm Akash and I'll be telling about the novelty of our project. So, for the novelty, we have seen existing disease prediction projects predicts the diseases based on any single algorithm in which we may or may not get the accurate results all the time because the problem here is no machine learning algorithm works best for every problem. There are many factors at play, such as the size, the structure, and number of records in data set. We aim to overcome this drawback with our innovative idea, which bring to the patients a diagnostic tool, which runs based on four different powerful machine learning algorithms and aggregates the optimal result by majority voting of results of all the algorithms. Our tool runs their specific numbers through these four algorithms to produce the optimal result, which is most optimal than other existing algorithms that are present right now. Every disease is predicted using four algorithms. They are decision tree, random forest, naive Bayes, and k nearest neighbor. While using a holdout test set of data to evaluate performance and select the ideal result.
So yes, thank you, Akash. So now we'll move on to the implementation. So basically, we have used these are trade testing data set, and these are the symptoms which we have used to test the data. First, we'll show on to training. So this is the training data set. So as you can see, these are the training data set, and we have all the symptoms listed here. And then last, we'll basically mention the all the diseases that are related to the symptoms. So these are basically all the diseases. And yes, now this is our testing data set, and here also we have listed all the symptoms and taxonomized all the symptoms on the basis of diseases. So yes, now this is our project. So yes, we have used the following libraries, and we have used NumPy, Pandas, OS, and these are basically the list of symptoms which we are feeding to this system. These are the 40 symptoms and more which we are feeding to the system, and these are the this list of predictable diseases which will be printed when once the user select all the diseases. And so yes, we have basically listed, we have read the training file and testing files using this, and we have used the prognosis to just select all the diseases and to replicate it and use it in our system. And this is the graph which shows the correlation between all the symptoms. And yes, we can see here listing of all the symptoms on the basis of numerals. So now we'll move on to the yes, and these all are the algorithms which we use. And we can see here that once we have to enter the name of the system, if we don't enter the name, the system doesn't take the input. First we have to start by entering our name, then we'll go on to the symptoms part, and we'll basically input minimum of 2 or maximum of 4 or 5 symptoms. These are 4 algorithms which we have used: the decision tree, random forest, KNN, and also name base. And we have also built a GUI using Tinker library, and these are the symptoms which 5 symptoms which we have taken input from user, and the input symptoms are calculated effectively. So now we'll move on to the implementation part. This is basically our GUI. And I'll begin by typing a name. So this is I'm typing my name, and we'll just put the four basic symptoms of any disease which a user is experiencing. So So basically, we can see that the final prediction here is all these algorithms are printing that these symptoms are basically related to less chance of COVID. So the final, since all these are showing only less chance, the final will be predicted as less chance. So the COVID prediction here tells that the although the user may have a chance of getting COVID, but it is very less. And while we change all the symptoms, the user might get different result, and he might get that he has COVID or he has no COVID, and so it is useful for him. So now we'll move on to the conclusion part, which will be shared by Bhavya.
Ma'am, to finally conclude about our project, we have therefore achieved our aim to develop a system that can identify the sickness of a patient based on the symptoms that are provided to our system. Then the user can then input their symptoms, and the program that we have developed employ four machine learning algorithms, and those are decision tree, random forest, naive Bayes, and k nearest neighbors, to predict the ailments and combine the final output to give the ideal sickness prediction that that particular person will have. So a device like that could relieve congestion or the crowds in hospital that occurs, and will lighten the burden of the medical staffs over there. We have finally succeeded in deploying such a system, and now we have employed four various algorithms also to accomplish this. We have finally managed an average accuracy of 94%, and this one such mechanism can be mostly trusted to do the task that we planned for our system. So, and also this has an easy to use interface. We have tried to make an easy to use interface for the patients, and it also has various visual representations of data collected and the results we have achieved. Thank you, ma'am.
Yes, now we'd like to conclude our project. So thank you, ma'am.